formula journal entry for annuities. Don't forget to put your name. And then the description of the annuities formula is regular fixed deposits. That means the same amount every month. Fixed deposits with a lump sum at the end of the deposit period. Okay, and our formula, we've got a great formula for this one. We have the capital F equals L times the quantity, a little quantity 1 plus little p raised to the capital T minus 1 over the little p. And we have to know what several variables are. So remember, the little p is R over N. Capital T is N times T. And then capital L is either going to be P times the quantity 1 plus little p, or just P. And this was with no interest. On the last payment or deposit. Okay, so those are all the variables, and where they go, we know capital F is still our future value. The big P here is the amount of the payment that we're going to make each month, and then the R is the rate, N is the number of compoundings, and T is time. So keywords that tell us that we are going to need to use the annuities formula, you might see deposits per month or per year, and then big chunk at the end. You decide to save money. Let's see if we can find anything here. It does say compounded and monthly and all of that, but here we're depositing some amount, and so that's the important part. On the first of each month for 36 months, how much will you have at the end of that time? The other problem, he plans to put money at the end of every month, so deposits every month or year. And maybe we'll put that as every instead of per. Every month or every year, and you get a big chunk out at the end. So determine whether final, and I should say deposit here, so I'll go ahead and do it for this. Determine whether final deposit earns interest. Then we'll calculate the little p and the big T, and then fill in the formula. And then use store and recall to help calculate. And remember, always we have to follow the order of operations. All right, I'm looking at both of these problems to see which one you want me to do. And I'm thinking this first one is saying you decide to save money, open a special account, 8% APR compounded monthly. You deposit $300 on the first of each month for 36 months. How much will you have in your account at the end of the 36th month? Now, the only thing excuse me, the only thing I think is confusing or could mess you up here is that your capital T is going to be the total number of payments, which in this case is 36. Other than that, I think that one's pretty much like what we just did. So I'm looking down here on number 2. Donald would like to retire with a $1 million nest egg, wouldn't we all? He plans to put money at the end of every month into an account earning 6% annual interest compounded monthly. If Donald plans to retire in 35 years, how much does he need to save each month? Now that sounds like we're going at the formula backwards from how the other examples were, meaning we're trying to find the P instead of the F. So I think that's the one I should show you. So let's try it out. So we have several things that we need to know. I'll scroll up just a little bit so it's on their screen. We need to know the rate, how much interest he's going to get, and the rate, it looks like, is 0.06. We need to know the N, the number of compoundings, and it looks like compounded monthly, so the N is going to be 12. And then we know he's retiring in 35 years, and it looks like he's putting money in at the start of the month. No, at the end of every month he's putting money in. So when you put money in at the end of the month, you can assume that you won't gain any interest on it by the start of the following month because it's only a day. So this one implies no interest on last deposit, and I'll have to write that up above. So that implies he's not getting any interest on his last deposit. So that means we can use the simpler formula, which helps a little bit. So we have our R and our N. We need our T. Our little t is going to be 35 years. And so then we can start calculating. Our little p is going to be 0.06 divided by 12, which is our n. And then our, which I think is 0.005 if I haven't forgotten. So 0.06 divided by 12, yeah, 0.005. So we just did that on the last example, 0.005. And then the capital T is going to be n times t, so 12 times 35. So 12 months in a year times 35 years. So we're thinking about what you're doing with that capital T. We're figuring out how many deposits Donald is going to make over time. So 12 times 35, he's going to make 420 deposits in his lifetime before he's ready to retire. So 420 for our capital T. Now I think we are ready. I'm going to write down that formula real quick from above. It's going to be F equals L. Remember, we either are going to have this little p, or the capital P times 1 plus little p, and that's if you have interest calculated on your final payment, and we don't. And so just the capital P if there's no interest on the final payment, so that's the one we want. So we'll just put, instead of that L, I'm just going to sub in the capital P already, and then the 1 plus little p raised to the capital T minus 1 over the little p. And there's my formula, so I'll slide down so I have a little bit of room to show it. I'm going to go to the right just a bit here, so I will, nope, can't do that. Not on this one. We might have to slide over there in a minute. We'll just go like this. Okay, so let's plug in the values. So I have F equals capital P So remember this one, we know the amount we want to end up with. So I have to write out $1 million. $1 million, so it's 1,000,000, and let's check it. That's thousands right there, 10,000s, 100,000s, 1 million. So that is 1 million. It has 6 zeros, and then we'll say equals, and we have our capital P times our quantity 1 plus our little p, which is 0.005, raised to the capital T, which was 420, minus 1 all over our little p, 0.005. And so I can see, if I'm going to be working on this formula, that if I calculate this whole part here, because there's no variables in there, I can calculate it and come up with a number, that I need to take this 1 million divided by whatever this whole big thing comes to find my P. And remember, I can calculate all this and then use my 1 over X button, or I can calculate all this and store it and then do 1 million divided by recall for what I have for this, whichever way you prefer. So I will show this on the calculator three different ways, and I'm not going to write down very much because I don't have any space left. Sorry.